Kubernetes cluster management with cluster API is the name of the topic today. I want to first have like a very brief introduction into like what is Giant Swarm, like what do we do, why do we have any idea about cluster API, or why might you be interested in what we have to say. So we are a managed Kubernetes provider. So we manage around more than 200 clusters, which are in production use. So this includes very large clusters to smaller clusters, but the complete cluster lifecycle is managed by us. And we do this on like multiple platforms like AWS, Azure, KVM, which is like on-premise. And in brackets here, I put AWS China. Why this is important, we can also discuss later on. But just know that AWS China is kind of a little bit different than the rest of the AWS world. So it's a kind of extra challenge we also tackle. And of these 200 clusters, we manage a lot of large clusters. So production-ready clusters, for example, for customers at Adidas or Vodafone, where we really manage clusters which have hundreds of nodes and have real productive usage and are like business critical for our customers. So with that comes obviously a sense of responsibility and urgency, especially in the realm of 24/7 monitoring, day two operations. But our main focus is still the cluster management itself, and then the day two operations and manage applications on top of it. So from here, you can kind of start to see, okay, we manage around 200 clusters. And what we have experienced over time, now over, I think, more than 4 years of doing this, maybe the 5th years approaching soon of managing Kubernetes clusters, is that with more clusters, you have more problems. So there's never a point where you can just scale up the amount of clusters you have and there's not going to be more problems. You encounter more weird stuff, you encounter more lifecycle problems. So everything gets more complex the more clusters you add. With one cluster, it's kind of controllable. With 10, 50, 100 clusters, every time there's a new step up in complexity. And more problems on the one hand means more operational logic, like you see the man on the right sweating profusely. That is like the horror of being on call if you don't have your system set up correctly and suddenly stuff goes wrong. And then you wish you had the hands at the bottom where you could just like type really fast and fix all the things manually. And that is kind of where cluster management comes into play there. You need to have a stable cluster management. You need to have all these day two operations set up correctly. So Cluster API kind of proposes to be a solution to this problem of scaling out your Kubernetes usage. So it really proposes that, hey, if you have 10, 20, 30, 40 clusters or 100 or 200 clusters, you can still manage them pretty well with Cluster API. And kind of the proposal statement I also put here is Cluster API is focused on providing declarative APIs and tooling to simplify provisioning, upgrading, and operating multiple Kubernetes clusters. So we see here multiple focus points. First of all, declarative APIs. We want to have this all declarative. Secondly, we want to simplify not only provisioning, like a lot of components in the Kubernetes space so far or in general, they simplify your provisioning, but they don't simplify necessarily your upgrading. Then there are some that simplify your provisioning and upgrading, but don't really do a lot of multi-cluster management. So with just kubeadm, you can handle clusters relatively well. But when you get into a fleet of clusters with hundreds of clusters, you suddenly need to build a lot more stuff around it, where like this tooling that is more or less intended for singular clusters or maybe a small selection of clusters doesn't really work anymore if your cluster usage gets much larger. So from here, we now want to see, okay, Cluster API kind of promises that it's a solution. So let's kind of discuss like how is it structured to achieve this solution? And then we can also talk about, does it really achieve this? And what are the open things that are still left unanswered? And for the first thing, I want to basically go into like from a very high level structure to a very low level in-depth structure of how Cluster API operates. So hopefully after this, you have a really good understanding of what is Cluster API and how does it work. And from there, we start at a very high level view. This is like a 10,000 feet view of like what is happening. Cluster API creates management clusters which contain the entire cluster API automation setup. So the management cluster is actually the one that spawns and manages these workload clusters. So on the right here, you see, for example, 3 workload clusters, and you have one management cluster managing them. So it's kind of Kubernetes managing other Kubernetes clusters. Pretty straightforward. You just basically have one cluster that has all the management tools and then rolls out the other clusters. Now, if we go one step deeper, we see, okay, how does this work in this management cluster? Like, how can we kind of achieve that the management cluster actually rolls out these workload clusters or upgrades these workload clusters or manages them? And for that, Cluster API bets on operators. So we will also discuss operators more in depth next, but I assume that most of you kind of have an understanding what an operator is. They're pretty far out in the Kubernetes community now. A very popular one, for example, is the Prometheus operator. And now we get like this slightly lower view of like there's a person that talks to the management cluster through kubectl or a cluster API specific CLI like clusterctl, interacts with this Kubernetes cluster, creates CRs for these operators, and then there's just a bunch of operators that roll out all workload clusters. So far, so good. Still pretty simple, still pretty low view of things. And now let's discuss like how does an operator work? I think this is very important, like just to reiterate, to kind of get the understanding of what is going to happen next. So I have this simplified view of how does a Kubernetes operator just basically work. And on the left side, you see a custom resource in the top left, which has a spec and a status. The spec is always the desired state. You should know a spec also from Kubernetes native objects. For example, a pod always has a spec where you can place what do you want the pod to do. And the status is the Kubernetes API, in this case in particular, the controller manager in the Kubernetes API, telling you what is the actual outcome of your action, like what's happening right now. And operators follow the same framework just for custom resources. We can again go back to a Prometheus operator, which is one of the most popular examples, where Prometheus operator, you have a CR called Prometheus, and you have an operator. And now we can go into what does the operator do, and that's the box on the right. And the operator in the first step has an observe step. What does the observe step do? It checks out the spec of the custom resource. So what has the user defined the custom resource or the operator should do? Then it checks the actual state. Let's go back to the Prometheus operator example. The spec would be, hey, I want a Prometheus with like 3 replicas. The actual state is the Prometheus pods which are running and hopefully have 3 replicas. So we go first on just an observe step. So the operator just observes this, first the desired state, then the actual state. Then we go around on this little thing and we go to the analyze step. The analyze step is simply, we compare what is the desired state from the user, like what does the user want and what is actually there. We do nothing else. We just compare what's the change right now. Is there a change? So on and so forth. And then we go into the act state. And the act state is basically, we take now action. You can see on the red arrow, we take action on the actual state. So for example, if you in your spec defined, I want 3 replicas of my Prometheus, but there's only 2, then the act state would add an additional replica of your Prometheus. And additionally, in the light gray arrow, you can see the operator additionally writes into the status what it has done or what it thinks the actual state currently is. So the operator would then write into the status, there's currently 2 replicas, I have created the 3rd replica. If we go back to the Prometheus example. And then we start over. So this is the basic workflow of any Kubernetes operator, really. So whenever you encounter a Kubernetes operator and you're not sure how it works, you need to know the spec is what the user or I want the operator to do. The status is what the operator thinks is the actual state and what it has done. And the operator goes through these 3 phases of observing, analyzing, acting, and reporting what it has now done. And the actual state is then the target of the operator. So now we can obviously apply this to clusters. Okay, this is basically the core assumption of Cluster API. We have this operator framework. What if we apply it to Kubernetes clusters? This is not maybe the uniquest idea ever because it was already done like pretty early when operators came out. But Cluster API is also a pretty long-living project. So the first release of Cluster API were in 2018. I think, if memory serves me right, but also in 2017, there was already discussion of doing this. So let's look at this from a very high-level view. We again have a custom resource, but the custom resource is now an entire Kubernetes cluster. We basically say we have a Kubernetes cluster that we want to have, like the desired state of the user is, please create a Kubernetes cluster. The operator goes through its phases and then would create an actual Kubernetes cluster, as you can see in the bottom left. It would hopefully create an actual Kubernetes cluster and then write whatever it has done into the status. Sounds pretty good, right? We are basically done. Not really, it's gonna get a lot more in depth, but this is the core idea behind everything. And from this core idea, we can already see a few positives of the whole thing. One positive is an operator is gonna continuously go through these three phases of observing, analyzing, acting, then it sets off. Which means it is automatically removing drifts from your actual cluster.
The microphone actually went off, or I can still hear you, but the sound quality is worse. I don't know if.
Let me try to see.
Yeah, I know it's a challenging thing, just in the middle of a presentation. So apologize for interrupting, but I think it'll be easier for people to follow if they actually have the same sound quality as they were used to. And it actually sounded a little bit better. Let's see. You probably just unplugged the microphone and we'll plug it in again. So let's see if it comes back on. No, I can't hear you yet. There's no microphone. Yeah,
can
perfect.
You hear me now?
Excellent. Thanks, we're back to perfect.
Yeah. It muted myself as soon as I unplugged the microphone. Sorry.
Great, thank you very much.
Troubles. Please tell me again if it happens again, and I will try to fix it. We were at operators managing Kubernetes clusters, and we were at a pretty high-level view. Obviously, this can work, and we can make up an example of, for example, our actual cluster, a node dies and is removed because we run an AWS cluster and just the EC2 instance just disappears into Nirvana. Because the operator is reconciling all the time, it will realize this and re-add back the node. Obviously not a super realistic example because there's auto-scaling groups and so on, but just to clarify the point. From here, we now, or you hopefully have a lot of questions in your mind, like how is a cluster defined? Do I just all put it on one resource? Are there always machines? What is the control plane? A control plane is a set of masters, just to make that clear, because that's a recent name change on the Kubernetes side. So whenever I say control plane, it's masters of a cluster. And when is a cluster actually ready? Like, how do I detect that a cluster is healthy? And is a machine healthy? How do I know? How does the operator know? And how do we structure all this code? So there's suddenly lots of questions when we go from this high-level view of we have an operator doing this to actually thinking about how does the operator find out, or is there a subset of operators that finds out? So it becomes very quickly very complex, and you can come up with lots of solutions as soon as you think about it. And I assume you also have some solutions in your minds. And from here, we can kind of discuss like what concepts does Cluster API follow? Now again on a pretty high level, and then we go deeper into the lower level. So Cluster API structures itself into multiple components. Here are the 4 main components it is structured into. One is the core component. The core component is basically just the glue that holds everything together. So it reports status of the other components and aggregates them into different places. It collects the status of certain components and forwards it to other components, so on and so forth. And then we have like 3 components which actually do real work, let's put it as work, which first of all is the Bootstrap providers. The Bootstrap providers are the ones that bootstrap machines or are providers for bootstrapping of machines. The infrastructure providers are the ones that interact with infrastructure, and we will get into that later. And the control plane providers are the ones that handle working with the control plane, because as you know, a control plane has etcds attached to it. You need to have like a special care for it. You can't just do some wild stuff with your etcds in your Kubernetes cluster. And the interesting approach Cluster API now takes is that the core component is always the same. So the core component, the glue between these components is always the same, but every other component is fully interchangeable. So we basically define APIs between the core component and every other component so that we can easily replace these different components. So for example, we can easily use a different Bootstrap provider or a different infrastructure provider, and you can even like mix and match. So that's kind of this approach we're taking here. And then we can see, okay, our picture becomes a little bit clearer because every one of these components is naturally an operator in our management cluster. So we can, where we previously had just like some undistinct operators, we now know, okay, there's at least 4 operators. These 4 operators have specific roles and interact accordingly. Now, another thing is that Cluster API tries to follow concepts that already exist in Kubernetes. So it's not trying to reinvent the wheel or build something completely custom. Where can we see this, for example? There are multiple approaches where how you could manage how are machines done, how do machines work, how do you manage your machines inside a cluster. And Cluster API kind of looked at, hey, how does Kubernetes manage pods? Let's just like copy the homework of Kubernetes and put it on Cluster API. So where in native Kubernetes you have a deployment, in Cluster API you have a machine deployment. So this is an actual CRD, so a type you can interact with, which is a machine deployment. And where normal Kubernetes or vanilla Kubernetes has a replica set, Cluster API implements a machine set. And where vanilla Kubernetes has a pod, Cluster API has a machine. So there's a kind of a relation of the concepts going on here, which should be very clear. And now we can also kind of understand where the core or where the glue code is coming from, because the interaction of like a machine deployment has a machine set with n replicas has n machines is a kind of this glue that I'm talking about, this underlying logic, which is normally in Kubernetes, now abstracted out into Cluster API, kind of applied on a different level. So we see these 2 core philosophies we're following. So first of all, interchangeability. Second of all, use familiar concepts. And from here, we can now really dive in deep as to what is happening. So we can kind of dissect how is Cluster API structured and how do I interact with it. And first, I want to talk about the core component. As I described, it's kind of a little bit of the glue, and it has the most similar concepts to vanilla Kubernetes. And you can see here we have one type, which is called cluster. The cluster type has like basic information about a cluster. So for example, you can give a cluster a name, which you address it by. That is in the cluster CR. You have a machine deployment, a machine set, and a machine, which we already talked about. But you have also a thing called a machine health check, which has different implementations to basically check, is a machine healthy? And from here, we can then go on to a Bootstrap controller, which we talked about briefly previously, which is kind of necessary to bootstrap a machine and will template bootstrap data for a machine. The most popular bootstrap controller currently, or bootstrap operator, is the kubeadm based one. So similar to how pods work, you can again see a machine has a bootstrap config and a machine set has a bootstrap template. This is similar to how a pod has a deployment can have a pod template, right? So following again the same kind of principles. And in these, you can then again define what is the bootstrap data I want initially on my machine. And you can use like kubeadm types to do this in Cluster API. So it's kind of a pluggable component. And right now, the pluggable component I'm choosing here is kubeadm. And it also handles the certificates to a degree. Then we have the infrastructure component. This is probably the most interesting one of the bunch we will talk about, because the infrastructure component is the pluggable component that deals with the actual cloud or non-cloud infrastructure and influences where is the cluster actually created. So for example, if you use the infrastructure component AWS, your cluster will be created on AWS, given you give it the correct permissions and so on. Azure on Azure and so on. Now you might be asking yourself, why is there an infrastructure cluster? Well, because the infrastructure component needs to create some stuff that is maybe only limited to the cluster. What can that be? That can be, for example, a VPC needs to be created, and that's independent of machines. The kind of the definition of a cluster is there has to be a VPC kind of, if you're talking about AWS. And then we go further down into machine templates again and infrastructure templates, where we then are on the level of AWS. This is an infra machine, is just an EC2 instance. And finally, we have the control plane component. I touched on this very briefly beforehand. The control plane component is basically the component that handles the control plane and ensures that it's acting in a sane way. Why is this a special component? Well, if we look at machines and machine deployments, they can just be replaced at any time, right? You can, it's similar to pods. You can just like take a deployment, scale it to 0, scale it up again, and it will be fine. A deployment in vanilla Kubernetes. But with the control plane, you scale it down to 0, suddenly no etcd is running anymore, or you scale it to 2 and then to 0, and you suddenly have a corruption in your etcd. You need to apply different logic here. And also with like upgrades, if you need to roll your nodes, you need to be a little bit more careful with how you do this with etcd, like is the state in etcd not going to get corrupted and so on. So that's why it's a special component and takes a special place here in Cluster API to really keep those needs rolling. What infrastructure providers are there? Loads of them. So this is one of the big strengths of Cluster API. I kind of put this in like 2 colors here. On the one hand, cloud, on the other hand, on-premise. On-premise, we have, for example, Azure Stack HCI, which is on-premise, Metal 3, Equinix Metal. All of these, or vSphere, are providers that you can run on-premise in your own data center. And then cloud, we have like the much larger selection, obviously, from Ali Cloud to DigitalOcean, to IBM Cloud, and then obviously the big ones like AWS, Azure, and so on. So this is really the most pluggable component and where the most different implementations currently exist. Now, you might be asking yourself, wow, that escalated quickly. Like we were talking about, you just have a cluster CR to suddenly there's all these fields, there's all these things going on. You need to set like some stuff in your machine deployment, you need to be careful of your etcd state and so on. So suddenly that escalated very quickly on the conceptual side as well. What I just wanted to show you here is, obviously there's a lot of different ways to implement this. Cluster API chose a specific way to implement this out of these motivations I tried to show. First of all, make it pluggable. Second of all, reuse things that people that use Kubernetes already know. Like everyone knows how deployment works. The machine deployment works all the same way. So what you might be asking yourself right now is, why should I use it? It seems pretty complicated. What's the big deal? And Now we can kind of talk about the benefits of this design. The number one benefit when or why you should use it is if you manage multi-cloud Kubernetes, in my opinion. So Kubernetes on a single cloud provider or like just on a cloud provider, for example, you have everything on AWS, might be pretty easy. You just have 3 clusters on EKS and you don't have big problems, right? If you suddenly have an organizational desire to have multi-cloud because you don't want to be locked in. So you want to have Azure clusters, you want to have AWS clusters. Maybe you want to have clusters on vSphere locally. It becomes a lot more difficult to manage all these different desires suddenly. And Cluster API gives you a consistent interface here that simplifies this interaction with the providers because the component is just pluggable. It becomes very easy to standardize across your different clouds. How this might look like, I took a little asterisk here because I have not tried this or done this myself in depth. Everything before this, I'm very in depth. Here, I'm kind of in depth. That's the little asterisk. So you can, for example, have your management cluster running on AWS while your workload clusters, so you can have the infrastructure component running multiple times in your management cluster, and therefore from one management cluster spawn different workload clusters in different cloud providers. So you can have your management cluster in AWS managing Azure clusters or AWS clusters or whatever else cluster you want. And that can also be AWS without EKS or AWS with EKS or Azure with AKS or without AKS. Both of these are all possible. So you can really mix and match for your desires. But the number one reasoning is you have all your management in one place or relatively one place, how you want to design your failover, obviously. And you have a consistent management interface where you can consistently work with these clusters without having to deal with everything's different on AWS, everything's different on Azure. I need to bounce around a lot. Obviously, another reason would be you need multi-region support. At the beginning, I quickly talked about China, why I put China in an extra bracket. Everyone that has been on AWS China before will know that it interacts very differently than AWS basically anywhere else. So it's really its own thing, AWS China that is, and it has like some features are just simply missing and so on. And Cluster API gives you a good abstraction level to still interact with these cloud providers in different regions, even if they don't have complete feature parity, because Cluster API can handle that in a kind of consistent way for you. Then one very obvious case where you might require additional management is on-premise. So on-premise is, in my opinion, always going to be difficult to manage for Kubernetes. There's not going to be one solution that you just plug in and everything works right out of the box without problems ever. But Cluster API enables you to have different on-premise providers and gives you a clear representation of what your clusters are on-premise. There are different on-premise providers which are already shown before, like Metal 3 or Equinix Metal, which build on top of Cluster API and implement Cluster API to give you these benefits of kind of a cloud-like infrastructure, but in your own premises. Obviously, there's always the disclaimer with on-premise, here be dragons, okay? Because even though theoretically we can say it's all going to work on-premise, I think everyone that has worked with on-premise installations knows there is always something different about every data center. And not everything is going to work out 100% with every security design or with every setup in your on-premise data center. And it might require some extra work. Just a disclaimer, I don't want to say you just use a Cluster API and everything's going to work on-premise, but I'm saying it is an improvement over what you have usually on-premise. And then the final point is why you might be motivated to use Cluster API is the extremely good integration with GitOps approaches. So GitOps has been an up-and-coming topic for quite a while now, and obviously it has become very popular. And for good reason, because having your state for your infrastructure, for example, in Git can be extremely beneficial for reviewability, for just like reproducing certain problems, for just like managing your entire infrastructure stack. And Cluster API gives you the perfect interface for this, because everything is based on operators and CRs, which you can simply put inside a Git repository and use any normal agent, like for example, Flux or Argo CD, to simply apply to your management cluster. And then the Cluster API operators will pick it up. So I just drew up this very quick workflow of like how GitOps interacts with Cluster API. And you can simply see you put the correct CRs into your Git repository, and Flux or Argo CD will understand how they basically work and apply them to your management cluster. And you have this GitOps approach very naturally. You can also check out some talks from Katie Gamanji, I think she's called. She has done several talks of how you can simplify your approach with GitOps together with Cluster API. So this is obviously, if you're already using GitOps or wanting to use GitOps, this is a very nice thing to have. So this all sounds very, very dandy, right? It's a little bit complex, but it sounds pretty cool. We can do a lot of cool stuff, and it just seems to work really well. So in your mind, you might be saying, what's the catch right now? Like, it sounds a little bit too good to be true and a little bit too easy to be true. And unfortunately, there's a few edges where you might get caught. So first of all, you need expertise to run Cluster API or to manage Cluster API itself. It's not as simple as you just start an EKS cluster. It doesn't hold your hand as much. There are varieties of ways you can basically destroy your cluster. And it doesn't have as many guardrails as maybe some other solutions have. So while you have a lot more freedom and a lot more pluggability and a lot more possibility, that comes with a price. And that price is you can still destroy your cluster unintentionally. That's just how it is, unfortunately. So kind of the price of freedom is you need to know what you're doing. And on the other hand, it gets pretty complex. We saw previously how these CRs are structured and how many there are. And that can get complex rather quickly if you're not familiar with operators in the first place, or if you've never worked with them before. And the last point I just want to make here, that there's no easy web interface coming from the open source community. Obviously, there are web interfaces. For example, we at GiantSwarm use Cluster API under the hood. You get a web interface. VMware Tanzu, I think Tanzu is the project called, uses also Cluster API under the hood, and obviously has a web interface. But from the running it yourself open source point of view, there's no easy to use web interface. So you can really destroy your cluster still a little bit. Additionally, you need to still manage some parts of your clusters. While the cluster is going to be set up and it's going to be a functional Kubernetes cluster, infrastructure outside of your Kubernetes cluster is not going to be displayed there. So databases that are running outside of your Kubernetes cluster, you still need to manage those. Additionally, components that are not installed naturally on a cluster you create with kubeadm, like the CNI, are not going to be there on a Cluster API cluster. So there's not going to be a CNI installed. So you have to take care of, you create a cluster, then you need to install your CNI. You may need to make sure that everything's working. Just kind of a disclaimer that even though Cluster API gives you a lot of benefits, you still need to do some stuff. It's not a solution where you don't need to do anything anymore. And now, rather minor disclaimer, but I still want to be honest about it and open about it, is it's still an alpha project. So if you go to Cluster API upstream, so Kubernetes 6 Cluster API, it's in V1 Alpha 3 right now. And the next one is going to be V1 Alpha 4, probably at the end of April. So there are still breaking changes happening. And the whole project is moving rather quickly. It's stabilizing as well, but I don't want to say there's not going to be any breaking changes, because obviously there are, and you will need to do those changes you need to follow up on upstream to get these changes in. That is a challenge that just currently exists, and that's why service providers basically do it for you currently. The good thing is that the representation is still the same everywhere. It's just that it differs a little bit between V1 Alpha 2, V1 Alpha 3, V1 Alpha 4, obviously. So there are some changes. So, okay, we saw there are some things you can get caught on, some things that can hang you up a little bit. So why do we as Giant Swarm, which is like one of the big things I said before this webinar, why do we believe that Cluster API is the future? Why do we think that this is really the way the community and Kubernetes as a whole is going to evolve in terms of cluster management? And there's like 4 points I want to make here that really come from our experience and that I just wanted to emphasize here. Number one would be less vendor lock-in. When you run EKS and you only run EKS and you build your entire tooling around EKS, this is a random example, same also for AKS or some other managed solutions for Kubernetes, you're extremely locked into this vendor suddenly because you've built your entire tooling around this one cloud provider. And from a Giant Swarm point of view, for our customers, Cluster API means less vendor lock-in because the same representation of the cluster is usable across different infrastructure providers. So the switch of using a different infrastructure provider becomes a lot easier with Cluster API, basically reducing the lock-in you have. Second point, in my opinion, one of the most important points is the extremely strong community behind this project. So it's not just a few people working on this in their free time. We are investing a lot of time into this project. Microsoft is investing a lot of time in this project. So there's full-time Microsoft employees working on this. There's full-time VMware employees working on this project. So the community of these providers is really rallying behind this project to an extent, so that you have people from Red Hat, people from Microsoft, people from VMware working together to form Cluster API into something that works for all of them and kind of preserves this no vendor lock-in status, and also works towards making this really a nice to use project. So that's why I think this extremely strong community support helps and gives it a good future for this project. It's not that someone is building this, but no one is really adopting it. The third point would be the conceptual basis is very good. We saw before that it takes some components from vanilla Kubernetes, but it also implements this pluggability. And it does that really, really well, in my personal opinion. And it's also a really big focal point upstream for the Cluster API project. So that is a very strong indicator for me that this is going to succeed. And lastly, from a Giant Swarm point of view, it's making our lives easier. So the life we are currently having with managing 200 plus clusters gets easier for us with Cluster API, which to me indicates that it's going in the correct direction. Obviously, your mileage may vary. So now you might be thinking, okay, kind of got an introduction to what Cluster API is. I kind of saw how it's structured. I saw a lot of positives. I saw some negatives. When, for me, like, or for you, is the time or the right time to switch to Cluster API or to consider switching to Cluster API? And I kind of thought about this beforehand because I also want this to make this kind of helpful for you. And I came up with a few different points in your Kubernetes journey where I would say this really makes sense for you right now to figure this out. And number one would be you plan to run a variety of clusters. So maybe you're in an organization or you just do it as a hobby, but you think that you will run clusters on multiple providers. You will have potentially a lot of clusters, and your clusters may vary in size and urgency, all that kind of stuff. Then Cluster API really comes out as the project that seems to be currently going in this direction and helping you. Because It is very focused on the variety of clusters. It is very focused on the variety of providers. So if you're at this stage, I would say evaluate Cluster API and see if it makes sense for you. Obviously, there are other solutions, but in my opinion, it makes very strong sense for you. Additionally, you already manage your clusters yourself. So you are already managing all of your Kubernetes clusters on maybe different providers, on maybe on-premise, and you have possibly a lot of them. It makes sense from a point of view of standardization from your side to make your life easier. And think like the viewpoint I would like to take here is if you're managing them yourselves or yourself, which is also what we did before we adopted Cluster API fully. And you have a strong community working on an open source project, the community eventually is going to overtake your homegrown solution, either in stability or in amount of features. And you have to find kind of the point at which you say, okay, right now, my homegrown solution is just not keeping up with the open source solution anymore. And does it make sense for me to switch now? So right now is a pretty good time to evaluate, in my opinion, if you are in this position, because Cluster API is stabilizing a lot right now. So if you're in this position, I would recommend check it out right now. If you think it's still not for you, maybe check it out in a half a year again, and maybe it will be a better fit for you. And then finally, this is like my favorite one. Your cluster sprawl is getting out of control. Okay, so you have clusters everywhere. You have clusters on AWS, you have clusters on EKS, you have clusters on AKS, you have clusters on vSphere. And all of these clusters are like, you need to kind of security update them. You don't know anymore how to do that because every cluster is somehow different. Now Cluster API kind of is, in my opinion, the way forward. Because once the sprawl has happened, it's very hard to catch. And there's always going to be some argument to be either on AKS or on EKS or to do something else. And Cluster API gives you like the streamlining of cluster management, which hopefully helps you contain the sprawl to make it not any worse and to take some management burden off of you. And obviously the main benefit would be you're not locking yourself into one provider. So what I've seen in companies happening or that I interacted with is a lot when they get to the stage and they have this sprawl where we have like different clusters everywhere and they can't manage them anymore, they just hard lock in on one provider. They just say, we put everything on EKS now. We just need to get rid of this overhead. Everything is EKS now. And I think that is not the correct way to go forward, or Google Cloud or whatever. That is, in my opinion, not the greatest way to go. And then finally, I also want to quickly talk about, because I didn't show any demo here, obviously, because I really want to explain the project without showing you a whole bunch of YAML files, to be honest, and without showing you a command line for like 25 minutes. So if you want to try it out and you want to see what the fuss is about, you can go to the, I will also, obviously the PDF contains the links. You can go to the Cluster API project, so Kubernetes 6 Cluster API. There's a quick start guide and an online book, which does an excellent job at getting you started locally in a kind cluster or Minikube locally on your machines. And there's a Docker provider also, so the infrastructure provider Docker is also available, which you can just run locally. So you can, on your own machine, have a management cluster and spawn workload clusters all on your own machine to really see how the interaction works and what it's like to use Cluster API. I just chose to not show it here because, in my opinion, it's a little bit boring to see. But if you want to check it out further, I would say this is the way to go, and the documentation is really nice.